Hey there, we're looking at the fourth grade textbook, chapter 6, comparing fractions and ordering fractions. Basically 6.2, and let's see what we have. We have 2/3 and we are comparing it to 4/5. Now, the Singapore book teaches 3 different methods on how to compare fractions, and in 5th grade, they start to ask you to look for common denominators. So our options here are taking the denominators of both fractions, which are 3 and 5, and go ahead and listing them out until we get to our first common denominator. So I can pull up here. We're going to create some multiples of 3, and we're also going to create some multiples of 5, or list them here. So we have 3, 6, 9, 12, 15, 5, 10, and 15. Our first match is 15. So the goal here is to take both of the original fractions and turn each of them into a fraction that has 15 as the denominator. So let's go ahead and do that. The way that it is typically set up, especially inside of the textbook, is like this. So we would say 2/3 equals something over 15. Again, remember we're changing our fraction to have a denominator of 15 because then we will have the same size pieces in each of our fraction bars or fraction circles or fractions in general. And then it's better or easier to compare them. So we ask, what do we multiply 3 by to get to 15? And we know that we are going to multiply by 5. And if you do it to the denominator, then you need to also do it to the numerator. So we're going to multiply by 5 on the top as well, which turns into 2 times 5 is 10. So 10/15 is actually the same thing as 2/3. So let's go ahead and do 4/5 as well. Remember, we're trying to get to something over 15, so we're going to write 4/5 equals something over 15. What are we multiplying by to get to 15? We're multiplying by 3. If we do that to the bottom, we have to do it to the top so that we're actually changing the size of both pieces, not just the number of pieces we have in our whole, but also the number of pieces that we currently are using. And 4 times 3 is 12. 12/15 and 10/15. Because they have the same denominator, we can actually rewrite our problem. So instead of 2/3, we have 10/15, and we are comparing with, instead of 4/5, 12/15. And which one is larger? We know that 12/15 is larger because the numerator is higher. So method 1 would be to find a common denominator. Let's look at method 2. Method 2 is where we are going to find a way to have the same numerator. So we're finding a common numerator. Let's rewrite our fractions here so that we can remember what they are. We're comparing 2/3 and we're comparing 4/5. So the first thing that we would do is we would ask ourselves, can one of the numerators be the same as one of the denominators? And in this case, one of the numerators be the same as the other numerator? And in this case, yes. We can multiply the 2 and 2/3 to be the same as 4, the numerator of 4/5. So that's the only fraction we're going to change there, is that 2/3. So 2/3, and we're trying, just like the last one, to figure out what we're multiplying by so that we can figure out the other part of our fraction. We know that we're trying to turn our numerator into 4. So what are we multiplying 2 by to get to 4? We're multiplying by 2. After that, we are going to multiply by 2 on the bottom because, again, if you're cutting the numerator into pieces, you're going to cut the denominator in the same exact way. So 3 times 2, and that equals 6. So we're looking at, instead of 2/3 now, we're looking at 4/6. We know that the numerators are now the same, and the fraction that has the smaller denominator, and the denominator, remind you, is the number that's on the bottom, denominator down, is a key phrase that I often tell the students. Whichever fraction has the smaller denominator is going to be the larger fraction. And the reason being is because you have larger pieces. If you had a pizza that you were sharing with 5 friends, you would get larger pieces instead of if you had a pizza that was cut to serve 6 friends. So again, 4/5 is larger because it has the same numerator, but a smaller denominator, making the pieces of that whole larger. So we had finding a common denominator, finding a common numerator, and now we are going to look at the third way that Singapore teaches us to compare. The last way that we would teach to compare is to compare to another number. Sometimes you're comparing your fractions to 1/2, sometimes you're comparing your fractions to 1 whole, sometimes you're comparing your fractions to 0. In this case, we are looking at 2/3 and 4/5. Both of those are super close to looking at 1 whole, so we're going to compare to 1. So for instance, I'm going to go ahead and I'm going to pull up 2/3 here. All right, so this is 2/3. This is going to be our 1 that we're comparing to. And then we have 4/5. Now, granted, we don't always have fraction tiles lying around for us to use, but you could always draw these on a number line to see the difference, or if you needed that visual. So let's look here. If we were looking at a comparison to 1, we could say, well, in 2/3, we need 1/3 to get to a whole, to get to 3/3, which is a whole, to 1. And if we look at 4/5 down here on the bottom, we need 1/5. In reality, we're comparing that 1/3 and that 1/5. We're saying which one of these fractions has less space to travel to get to 1, to get to that whole. And in this instance, you can see that 4/5 is the larger fraction because it's missing a smaller amount. This is our comparison by comparing to 1.